Good morning to all. Welcome to the course Environmental Engineering. So till the last class we discussed about basic introduction on water quality and water demand and then water supply. Then then after we discussed about various methods to protect the water source. The source may be a surface source or subsurface source. So in order to protect, what are the various methods followed? And then after we discussed the design period. We discussed about the design period, which is simply whatever the for which year you are designing. That is a design period from the current year. The difference between them, it is maybe a some certain number. That certain number is a design period. And then after that we are discussing about the population forecast. So now we are in the topic population forecast. So this population forecast is simply nothing but, as I told yesterday and also discussed two methods, but once again I am stressing this point. The population forecast is nothing but the design of water supply and sanitation schemes is based on the projected population of a particular city. So this projected population of a particular city, it is an unknown one. So in order to estimate the population of that particular city, after 20 years, 30 years, whatever the procedure, whatever the methodologies, whatever the calculations we are doing, that is towards to estimate the population in any particular city for the selected year. So estimated for the design period. This is actually a design period that whatever the for n numbers, after n numbers years we are calculating the population forecast. This is called as the n numbers. For example, n is a year, n in terms of years. If it is a 20 years or 30 years, actually this number is representing the design period. So estimated for the design period. Any underestimated value will make system inadequate for the purpose of intended. So what our intent, suppose if you without unnecessarily you fixed your design period as 50 years. So it is not required actually for water works, as I told in yesterday. For any water works, the design period must be 22 to 33 years only. 22 to 33 years only. So if you unnecessarily if you fix this design period as 50 years or greater than 50 years, it dilute entire objective. So it is not actually required, and also by fixing this design period as 50 years, the cost of construction gets increases. So entire this is actually called as a overestimation. And then if you underestimate instead of 22 to 33, if you underestimate around 15 years or 10 years, so it may serve for that much of period, but after that it won't serve. So it is also become useless. And these are the two examples for underestimation and as well as overestimation of the design period. So that's why, as we discussed in yesterday lecture, that the design period should not be the design period, whatever design period we are fixing, it should not too short and too large. So we must keep these two in our mind while fixing a design period. So this design period vary depending upon the work. So if it is reservoirs or dams, or if it is a building, the building structure, if it is a road, or if it is a waterworks, the design period may vary. But in any case, the design period should not be too small, too short, and as well as too large. So now we'll see what are the various factors affect this change in population. So we are estimating the population for the next 30 years from now. So for the next 30 years. So this is for example point of view only. So in this case, what are the various factors may increase, may possible to increase and decrease the population. So here the first one is increase due to birth, and decrease due to the death, and increase and decrease due to the migration, due to the rapid urbanization of all metro cities. The people usually migrating from different corners of the state to particular state capital, and due to this reason, the capital city or the metro city population got rapidly increases. So we need to be considered this. This is also one of the major point while predicting the population for the next years. Then according to the estimated number only, we usually design the works. So then increase due to the annexation. So this is also one of the it is not regular one. So like migration of the people, it is very rare case, but we need to be keep we need to be keep in our mind while predicting the population for in future cases. So then these are the various methods for predicting the population for the future. The one is arithmetical increase method, geometrical increase method, and incremental increase method, graphical method, and comparative graphical method, then master plan method, and logistic curve method. So out of these methods, yesterday in last lectures we discussed geometrical increase method and as well as geometrical progression method, also known as the geometrical arithmetical increase method and geometrical increase method. So as we discussed yesterday about these two, with a problem. So here one thing we need to be remember that this particular arithmetical increase method is suitable for the existing old cities where the growth rate of the particular city is constant. In that case only it is suitable. So whereas this geometrical increase method, this is suitable for the new cities, the cities which are planning develop like Amravati of Andhra Pradesh. So it is one of the new city. They after bifurcation of Telangana from Andhra Pradesh in 2014, for the residual city, the government of Andhra Pradesh has been selected Amravati as a new capital. So in that case, to estimate the population for 2030 and 2040 or 2050, so then you can use this method. So with the for reference to reference population, here it is 2011 one, because we have the data till 2011 the government of India. So this is a reference one. So then we using this reference one, and by calculating the previous decays increment, then we can calculate 2030, 40 or 2060 also. Wherever you want, you can calculate using this method. So as I discussed about these two methods yesterday, and in present lecture we will discuss about incremental increase method and graphical method and comparative graphical method. So just overview I'll give you on it. So here incremental increase method is a modification of arithmetical increase method. So just modification of the arithmetical increase method. So and it is suitable for an average size town under normal condition where the growth rate is found to be increasing in order. So if you select any city, if the city growth rate, the population growth rate of that particular city in normal condition, in the it has to be increasing in order from the if you see the previous decades, it has to be some increasing in order. So in that case, you can use this method. So this is the small modifications from the arithmetical increase method that we'll see while solving the problem. What is the exact modification incremental method to the arithmetical increase method? So while adapting this method, the increase in incremental is considered for the calculating the future population. So that increase we need for example, if you take any 2 years, 1971, 1981. So here there is a population say x1 and population say x2. So here we need to be identify what is the increase in between these two. So here, and the incremental increase is determined for each decay from the past population. So as I told, we have 2011 is a reference, and before that we have 2001, and before that 1991, 1981, like this. So from the past to each decay we have to calculate the incremental increase from the past data, and the average value is to be added to the present population. The present population is nothing but the latest one. 2011 census is the present population. If the government of India is recorded will do regarding data for 2021, these become a present population. So till now it not happened due to pandemic, and then see now we can estimate the forecasting population by using incremental increase method with this formula. Whereas p suffix n is nothing but population after nth decay. Whatever the decay you are calculating for 10 years after, from 2022 or 2021, 20 years and 30 years, this is one decay, 1, 2 and 3 decays. So here, and whereas the p is the present population, means 2011 population, and n is for which years difference you are calculating, whether you are calculating for 2 decays, 3 decays or 4 decay or 1 decay. So this become changing uh, according to the requirement. And this x is that average one, which just now I told here, we need to identify a mean difference between the population, and we need to, that the average will be here x. Again it is decay wise only, and then y is the average of incremental increase. So this is the difference while compared to the previous arithmetical increase method. So here we'll get the y. Previously, in case of arithmetical increase method, we just quoted one assumption that rate growth of the population with respect to the time is equal to constant. So here it is, we need to be identify that incremental increase for each decay. So that's why here each decay from the past population need to be calculated. So then we'll take one problem on this, the similar problem which I considered for the last two examples that I'm considering here also. So here we need to predict the population for 21, 31 and as well as 41. So with this data, so here if you write year and population, year and population, and as well as increase, and then it is incremental increase. This is the one added one. So here it is 1961, 1971 and 1981, then 1991. The given this is a completely given data, and 2001 and then 2011. So here it is, the population is 8,58,845 and 10,15,672. Then 12 lakhs 1,553, and then 16 lakhs 91,538. Then in 2001 the population is 20 lakhs 77,820. In 2011 it is 25 lakhs 85,862. Now the difference between these two, we don't have any previous value to this 1961. If we have 1951, then we need to be considered as a that is the first one. But here we don't have any value before 1961. So here there is no incremental value. Whereas to calculate the incremental value in this particular 1961, it is just simply the population in 1971 minus population at 1961. Similarly, if you want to calculate that population in 1981, it will population in 1981 minus 1971. So then if you want to calculate at 2011 increment, it is equal to 2011 population minus population at 2001. So now after calculating, after subtracting this value from this from the previous values, here it is the increase in population in 1971 while with reference to the 1961 population, it is equal to 15,7,127, and then 18,588,1, then 48,9,985, then 38,6,282, and in 2011 it is 50,042. So this is the increase in population. So now incremental increase, here to get this incremental increase, we need to do population in 1981 minus population in 1971. So here we don't have any value here to do the to identify the incremental increase between these two, and here also we don't have any value. And now here we will get some value, because here we have two two decays population. So here we will get the value wise. So now you will get here it is 28,754. 28,754. And Coming to calculate the difference at incremental increase in the year of 1991, it is 1991 population increase in population, 1981. So it is simply that 48,985 minus 85,881. So this we have to do. So the difference here it is around, we'll get nearly 30,000, sorry, 4104. Similarly, increment in 2001, it is in 2001 it is equal to minus 103, and then in 2011 it is equal to, so this got increased. Here it is decreased due to various reasons, and it is also this. Now we need to calculate according to our formula. We need to be calculate. We need to take out the average. First, we will do the total. Total for in both the cases, the total is 17. In this case, total how many? 1, 2, 3 values. It is equal to 915. The average we need to be calculated again. The average is same, the total divided by 1, 2, 3, 4, 5 values. So it is, the average will come here, it is 34,5463. Whereas here the average it is 87,729. So this is a way of calculating the population in so this is not yet solved still. We need to calculate the population in 21, 31 and as well as 41. This is the basic data we will use for the calculation purpose. Now once if you see this formula, it is equal to P suffix N, nothing but here we are for this particular year. Here it is known one, nothing but here you can write 2021. We are calculating 2021. So then P equal to P plus N into X. I'll write one second formula here. It is P N equal to P into N X plus X plus N into, this is one is X plus N into N minus 1, sorry, plus 1 divided by 2 plus 1 divided by 2 into Y. This is the formula. So now I need to substitute all these values here. So here, whereas Pn is nothing but I am going to calculate for 2021. You can write it as 2021. It is equal to P is a known population, that is 25,862. So this is a known one, and we are calculating this N. This is N is nothing but plus N into X. This N is nothing but the 2021. We need to calculate for 2021. The difference between 2011 to 2021 is 10 years, nothing but 1 decade. So it becomes 1. And into X value. This X is the this X is the this one average of this incremental value. So that is equal to 54,54,63. So then plus 1 plus 1 decay 1 by 2 into Y is nothing but the average of increase in incremental value. It is equal to 87,729 here. So now if you substitute here, if you calculate this, we'll get the population in 2021. It is equal to 19054. So similarly, if you want to calculate the population in 2031, it is equal to again same 25,85862 plus here it is just only difference is it is 2, because Now we are calculating for 2031. 2011 is our reference value. 2011, 2021 and 2031. Here it is 10 years and here it is 10 years. So 1 decay, 1 decay. This becomes 2. So this becomes 2. So here it is same, the incremental increase average is same, and then it is equal to, now it is 2, then it is also 2, and according to the formula it is 1 divided by 2, and y is away again 87,729. So then you will get the value here. It is equal to population in 2031 equal to and 75. This is the population at 2031. So now if you want to calculate the population in 2041, again we need to take the n value as 3 because we are calculating for 2041. So then in case of 2041, it actually becomes the number of decades are increasing to this number. So it becomes one more number will be added here and it become 3. So again you have to apply the same formula for 2041. It is equal to P. In this formula it is P equal to 25, 85 and as well as 862. Then which decay we are calculating? For decay number 3. 3 decays after 2011. So then it become 3, and the average value of incremental increase, sorry, arithmetical increase 1, and it is equal to 345463. Then plus number of decays is for 3 decays after 2011 we are calculating, so that it become 3, and then just substituting, I am just substituting the formula, that is this y value nothing but the average of incremental increase method value, that is equal to 87,729. So once after solving this one, you can get the population in 2041. It is equal to 414,8625. So this is the way of calculating the population forecast using the incremental increase method. So the difference between the incremental increase method is well compared to the arithmetical increase is, previously in case of arithmetical, from any 2 decays we just calculated the difference value between these two. Similarly, we also calculated the difference between these two, and so whereas in this method one more change, that is after getting the difference value from this, then what is the incremental increase? What is the incremental between after getting the value of difference from that difference value? We identify the we calculated whether that difference got positive or negative in that way. So that is the main difference. So if in order to perform the in order to calculate the population forecast using the incremental increase method, we supposed to do the arithmetical increase method first. Then only that this method is simply extension to that one only. So this is the then after we'll discuss about the graphical method. So it is very simple actually. General way I'll tell. In this method, the population of last few decades are correctly plotted to a suitable scale graph. For example, you just assume that this is the last few decades population. So the population of last 2 decades are correctly plotted on the suitable scale on the graph. So the population curve is smoothly extended for getting a future population. So we are just extending that curve. Once after getting this curve, for example, this is the curve of the known population. This is the known population. Then we are extending this one like this. So then the extension should be done carefully, and it requires a proper experience and judgment. Whatever the extension you are doing without doing any calculation, just using this graphical method. So in order to fix this population according to this method, we must need some good experience in that and valuable judgment. So the best way of applying this method is to extend the curve by comparing the population curve of some other similar cities having the similar growth condition. So this is we can refer this one with the few cities, like for example, if I am calculating the population forecast for 40 for Bangalore. So in that case, we are supposed to consider the similar cities, similar metro cities in all the conditions. They according to their population growth should be in similar manner. So for example, I supposed to compare this with the population curve of some other similar cities. So here I need to select some other similar cities in population growth rate. So for example, if I consider if I am doing population forecast work for the Bangalore city of Karnataka, then in that case I supposed to consider the few similar cities like Hyderabad and Chennai. So then Kolkata, like that I supposed to consider. So those whatever the reference cities we are considering, those cities population should be in similar manner, So now we'll take one problem on this. You see, so here just example purpose considered here. Now you see we need to plot this graph between population and in population and as well as years, and this is a population growth rate. You can see these are the known values. These are the known recorded values, like what we discussed in the previous problem. You can say the same known values, and this is the from the year to year. Nothing but so it is nearly after 2001. Nearly after 2001, this population got estimated using graphical method. So we didn't follow any previous method like arithmetical increase method, geometrical increase method, incremental increase method. Just only this is a known one, and to this one is we simply extended this curve to like this. Suppose one can may extend like this, one can may like go with this dotted line, one can may estimate like this, like this. So there will be a obvious difference between it. So then, for example, if I want to estimate the population according to this method for 2051, then I have to extend this curve till 2051. Then I have to draw one straight line to meet this 2051. Then one horizontal line in order to estimate the population. So here it is population in lakhs. So we can estimate easily the population in 2051. Similarly, if you want at 41, 31, 21 also, you can estimate using this one. But this is actually not preferable because the person who are doing the estimating the population using this method, he is supposed to have vast knowledge on that and is supposed to use some good judgment. So then only we can give some good results. So now we'll take one problem on this graphical method. The same problem I considered again here. So here the question is I need to estimate the population in 21, 31, 41. So now if I draw this, if I plot this on the suitable scale on the graph, it is equal to, you can say here it is a population in lakhs, whereas it is years. So here they given very clearly years it is. I'm just taking I'm just taking from 3, 6, 9, 12, 15. 18 and 21, for example. So and the corresponding year I have here. So it is take it as 1951, 1961, 1971, 1981, then 1991, 2001, and then 2011. So this is the known data. Actually, now I need to calculate the I need to estimate the population in 21, 31, 41. For that, I am just extending this one like this. So here it is for say 21, 31, and 41. So now this data already we have till 2011. You just plot on this graph like. So it is around 8 lakhs. So somewhere we will get here 8,58,000 is starting point. So you just put one mark, and then 10 lakhs in the next decade, that is 1971. Here it is. We'll get somewhere here. We supposed to do corresponding to this 1981. So then in 1981 it is 12 lakhs. So 12 lakhs exactly. And then sorry, it seems a little high. uh, it is like this. And in 1991 it is around 16 lakhs. So here it is 15, then we are supposed to go to the 16. It is somewhere here. Okay. Then in 2001 it is around 20 lakhs. It is around 20 lakhs. So we'll change these values actually, because it seems. So then go for the make a difference with the 5, 10, 15, 20, 25, 30, 35. So again have to relocate. So in 1961 it is 8 lakhs. So then we will get somewhere here, and near to this 10. And in 1971 again it is 10 lakhs. Then 1981 it is 12 lakhs. So here we will get in 1991 it is 16. And in 2001 it is 20 lakhs. So then you see we need to be supposed to draw corresponding to this one 20 lakhs 77 something. And then in 2011 it is 25 lakhs. So we need to mark on this point. So now we need to estimate the population in 2021 and 2031 and as well as 2041. So according to the graphical method, you need to draw one solid line by touching all these curves. Then now I need to extend this curve with a dotted line like this. So then this dotted line corresponding to this 2011, this dotted line corresponding to 2021, not 11 already it is known value, it is 25. So then 2021 I need to extend this one like this. So then corresponding to 2021, corresponding to 2031, corresponding to 2041, this is the population. Now we can see how this population got increased. So here it is 35, you can say 40, then 45, 40, then 45. So now we will fix population at year. So this is the method. This data line is got extended to obtain the value between 21 to 41, because already we know the value till 2011. So then some x1, x2, x3 value I'll get here. So these x1, x2, x3 population we must compare with the similar cities. So how they estimated the population corresponding to 21, 31 and then 41. So then we'll fix our values are little. We need to, if you compare, if they seems good results, then we can adopt it. Otherwise we need to change this method. So with this method there is a lot of possibility to get overestimation and to get the underestimation also. So that overestimation, underestimation leads inadequate the success. So that's why this method most of the people may not be prefer. And then the comparative graphical method, this is another method. And in this method the census population of the cities already developed under similar conditions are plotted. So for example, already the census population of cities already developed on similar condition will be plotted on the graph again, and the curve of the past population of the city under consideration is plotted on the same graph. So for example, I want to calculate the population for Bangalore city. I usually consider a few cities as I told like Hyderabad, Chennai and Kolkata, like that. So here the curve is extended carefully by comparing with the population as like similar previous method, population curve of some similar cities having the similar condition. So then the advantage of this method is that the future population can be predicted from the present population even in the absence of some of the past census data. So here we have data till 2011. Suppose for example, if we don't have a value between 91 due to any reason, then we can extend this graph 1990. So I'll tell with example. This value we have, and here we don't have the value. In this case we don't have the value, and this is the symbol we need to be extended one, we need to be draw with a straight line, and then after that this is known value again. So this part is an unknown value, here not calculated in 1991. For say for example in 1991 not calculated. So in this case to get the population in 1991, we just extended the curve from like this. So this may be underestimated one, this may be overestimated one, but we can consider this as a base to calculate the in case of absent of some particular decay population, we can consider this graph, and we'll get the results even in absent of some of the past census data report. So now you see some problem on this. So it is let the population of new city called X be given for decays 1970, 1980, 1990, 2000, were the population corresponding to 1970 32,000, population corresponding to 1980 it is 38,000, and similarly population corresponding to 1990 is 43, and for 2000 year it is 50,000 respectively. So this is the population of this X city. So total how many years they given? 1, 2, 3, 4 cities. Sorry, 4 decades. 4 different years they given. Then the city ABCD were developed in similar condition. This is some reference data. City called ABCD. The reference data in similar condition they are developed. Now we need to consider this as an example to estimate the population for the X city, and it is required to estimate the population of the city X in the years of 2010 and 20. We need to estimate the population because here we have population till 2000. We need to estimate the population in 2010 and 20. We don't have any previous data related to X city. So just we have the data, previous population data for ABCD cities. So then those previous data you can see here for city A, for city B, for city C. You can see for 1960, 1972, 1980, 1990. So then we need to calculate for 2010 and 2020. Very simple. This is, you can see the population curve for the cities ABCD and X were plotted first. This because here we have complete data 1960, 1972, 1980, 1990, and for few others different there is small differences in years, but we have the data with respect to these years, these years. So just we need to plot on the graph again by drawing the population versus time. You can see now this is a time in terms of years and population in terms of thousands. So then just simply plot on the graph. For example, if you take city A, I'll draw here only, and this is the 19. Say for example, it is 1950, 1960, and 1972. Directly I'm writing 72, 80, and 90. So here we don't have any data, so we leave it 1950. Then coming to 1960 onwards, we need to mark. First year it is, you can see the maximum population out of the city is 87,000. So it is say 90,000, and then 80,000, 70, 60, 50 like that. So then and 40. So in 1960 it is 50, and in 1972 it is 62. This is the 60, and here we get the 62 for the with respect to the 1972, and then for 1980 it is for 1980 it is 72,000. So for 1980 it is 72,000, and for 1990 it is 87,000. This one you get here. So we need to draw a curve like this because this is a known data. We are not extending. That's why we'll go with a solid line. So similarly, this is, you say this is for city A. This is for city A. Similarly, we have to draw a curve like this for city A, B, C, D, because we considered there similar cities are 4. See, those are A, B, C, D. And now we need to calculate the X city. This is our we are calculating X for X city only. So the X city population also given for these corresponding years. So till up to 2000 we can draw with the exact values. That's why it is a C solid line for the excessity. You can see this is the excessity and then solid line. Then now as I compared with this previous cities ABCD with X, so this is somewhat mean there is a lot of difference we can observe. We can observe here population growth rate, and then simply to obtain the value in 2000 for 2010 and 20, just I extended using the graphical method. So if I then I want a value at 2010, so I supposed to draw a straight line here, and then if I want to value at 2020 again I supposed to draw one straight line, and then this straight line has to merge with the horizontal one. It become like this. So here the population is here the population for 2010 it is nearly 58,000. You can see now. So it is nearly 58,000. It is nearly 58,000, and whereas for 2020 the population is nearly 68,000. Somewhere we will get here. Somewhere you will get here. So it is 68,000 for 2020. We are supposed to calculate the population forecasting with the comparative methods like this. So then you see another dotted line is there in between A, B, C, D. This is the mean of all these four cities. Mean value of all considered four cities. So you I'm just giving some concluding point on this. That is first we need to given population we need to plot on the graph, then extend to required one. So this is the way of representing the extended population. This is the known population. So this extended we need to be with this. We can get the population of our city, then we can fix the population, because the fixing the population for n decade is very important. That is called as design period actually. So then we'll get like this. So in comparative graphical method, we need to compare this extended whatever we did in graphical method that with the any other four cities like A, B, C, D. So then we will identify that. You can see easily the difference between these two. So here it is the population is nearly 58,000 in 1990, but our excessity data is population is nearly 40,000 only. So we have a chance to compare, and then we will take the we'll fix the design period and we'll fix the population with this method is somewhat there may be a possibility for overestimation and as well as underestimation. So with this I'm closing today's lecture. Thank you, and we'll discuss the few other methods in the coming class. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.